All right, students. So here we are with a little bit more number theory. We're looking at divisibility. And the idea here is using the basic idea of divisibility that we understand, and then also some of these theorems and lemmas that were shown throughout the chapter, and to prove some things. So I'll let you work on the numerical examples yourself. If you want me to do one, I can totally do that. But I'll do just a couple of the proof ones, and then of course you can ask for more. So I think a really important one is like number 3 right here. If A divides B, so we're going to assume A divides B. I'll just write assume. Assume A divides B and B divides C. And we're going to try to prove that that means that A divides C. And so if A divides B, what that means is that B is equal to AN for some integer n. And similarly, B divides C means that C is equal to BM. I'm going to use a different integer because there's no reason to assume that the same integer would work for the second divisibility. And so what that means then is when we're trying to prove that A divides C, what that means is C equals BM, but B is equal to AN. So we have ANM, which is equal to A times K, and K is an integer. And that proves that A divides C. Because when something divides another thing, that means there is an integer that you can multiply A by to make it equal C. And I proved that. N times M is an integer because both N and M are integers. So that's kind of the idea behind these proofs is you're using the definition, you're doing some a little bit algebra manipulation to prove what you want. So I'm going to do number 4 and then number 7. So let's look at number 4. So again, I'm just going to assume this. I'm not going to rewrite it on the screen, but I'm going to assume this. And we want to prove that A divides B plus C. So I'm going to start with B plus C. I'm going to write that as NA plus MA because A divides B and A divides C. So I hope you can see from how the example I just did lets me do that. I can factor an A out, and that allows me, if you think about the distributive property, to write it like that, A times N plus M. And we can call that A times K. And so what we know is B plus C is A times K, thus A divides B plus C, just as requested. Now, the second one, part B, is almost identical. We just need to do basically the same thing, that BR plus CT equals NAR plus MAT, and you have the same idea, A times NR plus MT, which is equal to A times, I won't use K again, I'll just use P. And so there we go. We've proved exactly what we needed. Now I want you to point out that number 7 is pretty similar to what number 4 looks like. It just switched the if and the then. If and the then. And so let's look at number 7 and see what happens. So we get to assume that A divides B plus C. And what that means is that A times K is equal to B plus C. But from here, I can't really do too much. I can't really do too much at all. As a quick example, if I have, let's have A equal 5 and B equal 1 and C equal 4, then this is true. 5 does divide 1 plus 4. But 5 doesn't divide 1, and 5 does not divide 4. So it does not divide, has a little slash through it. And so I want you to take a second and think about the difference between question 4 and question 7, how it's switched to the if and the then parts of it, and how you really did need to know for part 4 that the A divided each of the original terms before you could conclude that it divided their sum as well. So I'll call that good for this video. In the next video, I'll try to tackle a couple further down that are a little bit trickier.